Buongiorno a tutti. Allora, come sapete, oggi scusate, abbiamo una mattinata dedicata all'HPC. Abbiamo degli ospiti particolarmente... Non si sente? Abbiamo degli ospiti particolarmente graditi e la giornata inizia con un saluto da parte del delegato del rettore e poi avremo le presentazioni dei tre ospiti. Do la parola al delegato del rettore e poi vi presenterò gli ospiti. Prego, professor Ferri.
Grazie infinite. Non temete che non è come la battuta, non sarò breve, ho 150 fogli, ma solo un piacere grandissimo aver conosciuto le due professoresse e rivedere ora in una circostanza lieta, qualche giorno fa in una circostanza non lieta, Paola Inverardi, che ho avuto il privilegio di avere per rettrice per un sessennio e che ora prosegue nella sua attività di rettrice in un'altra veste ultra tecnologica. Vi porto i saluti di Edoardo Alesse, che in questo momento è impegnato in un'altra sede, e come Ateneo siamo ovviamente più che felici di questa iniziativa che io godrò ovviamente perché amo la cultura e tutto ciò che è scienza, ma comprendendo probabilmente neanche una sillaba di quello che direte, perché tutta la mia attività tecnologica è volta a capire come si accende il cellulare la mattina e come si usa il telecomando dell'aria condizionata a casa con grandissima difficoltà. Però come dicevo prima, ma ho scoperto che me lo hanno insegnato loro, lo sapevano perfettamente, quello che io chiamo il supercomputer a noi medici serve moltissimo. Prima i farmaci venivano sviluppati o per serendipiti, la penicillina nasce così e non è poco, o perché c'era un tecnico, quindi un giovanotto della mia età, che si mette lì, prova 150 composti che hanno un idrogeno di differenza e dice beh, proviamo questo che mi sembra più lipofilo, andrà bene. Era il caso. Adesso il computer ti dice da prima prova questa cosa qui, funzionerà, e infatti vedete che i farmaci si sviluppano nell'arco di 1 anno, 2 anni, non di 10-20 anni. Quindi sarà un grandissimo piacere ascoltarvi, imparerò un sacco di cose, non credo, è una penosa bugia. Benvenuti a nome di tutto l'Ateneo e ridò la parola a lei, professoressa. Grazie infinite.
Allora, buongiorno a tutti, grazie di essere venuti. E volevo introdurvi gli ospiti, gli speaker di oggi, che ci faranno una presentazione sull'HPC, The Engineering of Innovation and New Opportunity in Europe and Italy, che significa che l'idea era di dedicare questa giornata di fatto ai giovani, proprio per dargli idea di quali sono le opportunità in questo settore. Non si sente? Facciamo così. Non so se così va meglio. Anche le presentazioni?
Ah, ok, quindi
non lo so. Le presentazioni le fate in inglese o in italiano? Ah, in inglese, ok. Scusate. Ah, ok. Non avevo... perché le altre presentazioni le abbiamo fatte in italiano, quindi non sapevo. Allora, quindi oggi we have 3 speakers that are dottoressa Dr. Gabriella Scipione, Professor Paola Inverardi, and Dr. Fabio Di Sante. I'm going to present all of them now, and then I will give you the opportunity to present your presentation. So, Dr. Gabriella Scipione, she is from CINECA, and she had a PhD from University of Bologna. And she is currently the head of the data management and data analytic division of the CINECA HPC division. And her teams is focusing on big data management and on developing some kind of, let's say, application for visualization of this application, right? Then she has been the technical project manager and the coordinator of several European projects in weather, climate, and environmental and life science. She has been the coordinator of Leonardo EuroHPC computer proposal for bringing the computer in Bologna, and she succeeded, it's my impression. And she is also the technical advisor of the Italian Ministry of the Education, MIUR. And she's involved in praise, and she actually is holding the role as council delegate of Italy. Then I believe that everybody knows Professor Paola Inverardi. She's actually director of GSSI. She was our rector previously, and she was also our head of the science faculty. And she leads the software engineering and architecture research group. And her main research area is the application of rigorous and method to software production in order to improve the software quality. And she is in the board of the IEEE Transaction Software Engineering Springer. And also she has a chair in leading the conference in software technology. She's the chair of ICSC steering committee, member of ACM European Council, and member of the Accademia Europea. She also received an honorary doctorate at Mälardalen University in Sweden. You may pronounce it better than me, the name of this university. And she received a prestigious award from the IEEE in 2013 for outstanding and sustained contribution to software engineering community. Then finally, Dr. Fabio Di Sante, she was our student at University of L'Aquila, and then he got a PhD in Trieste on earth science and fluid dynamics. And he worked for several years on developing and applying coupled atmosphere and ocean river regional climate models, and to investigate the impact of climate change on regional weather patterns. He joined the CINECA in 2022, and now he is working on porting and optimizing weather and climate models on the architecture for the new architecture using the GPU. And he is actually still involved in the development of the weather operational chains, I believe. And that are really complex systems, I know that, for generating the weather forecast. So, please, who is starting? Professor, okay. So, Professor Paola Inverardi, please. Grazie.
Allora, in inglese, quindi. Okay. Let's go in English. No. I'm not showing anything since I'm going to present actually the geopolitical landscape of high-performance computing in Europe and in Italy, which actually I think it's important to know because gives to all of us the idea of the directions in which investments in terms of funding, European funding and national funding are in this area. and also give an idea of the kind of involvement and the perspective of development of high-performance computing, so that then the technical presentation will actually focus on more technical issues. But I think that it's important to convey the message that since a few years, high-performance computing is not anymore closed in a niche of interest, also scientific interest, especially of certain kind of communities, scientific communities, but it's trying, and this is the political idea, the political push, European push, is trying to exit these niches to actually be much more available to a wider audience, and in particular to companies, especially to medium range companies that cannot afford to have this kind of computational power. Now, and then I will go to the geopolitical, but just to close the circle of this high-level presentation, now it's even more important, as you know. I mean, the development of large language models since last year, it's only last year, it's 2022 actually, now 2 years almost, because we are beginning of 24, but it's only 1 year that we have seen this extremely important development witnessed by ChatGPT, but the real, I mean, to some extent, the jump that this kind of technology has made is entirely due to computing power. So actually, if you, I mean, all of you probably know, I mean, in OpenAI, who is the developer, that is the developer of ChatGPT, they managed to move from the performance of ChatGPT 3 to 4, which is the real jump, because they had a huge investment in computational power. So adding power, it's brute force. I mean, it's brute force. However, what we see now, and we can see, I mean, we can observe now, it's due to the fact that a huge amount of computational power has been devoted to training this kind of technology. And now we are talking of this kind of technology like a daily technology. It might not be like that, but this open another meeting, maybe, but it's just to tell you that, I mean, corresponding to this, also Europe has been changing a little bit its strategies, trying again to push towards this line of research. Now, let me just use 5 minutes to tell you what's going on in Europe and what's going on in Italy in this field. So in Europe, a few years ago, was set up this joint undertaking. That it means it's a European initiative where a set of countries come together with the European Commission and say, okay, we would like to invest on this topic. We will put half of the money, the countries, you, Europe, put half of the money, and we will develop this program. And this was done for, I mean, to promote high-performance computing, to equip Europe with a high-performance computing infrastructure that could actually compete worldwide. It was not like that a few years ago. And then, I mean, this was the birth of a EuroHPC Joint Undertaking initiative. I am the Italian representative in the European, in the governing board of EuroHPC. I was named a few governments ago. Now it looks like I remain. Maybe I don't know, but it's so. And now are a few years that I'm there. Maybe Gabriella remembers better how many years. Maybe 99. I was not rector anymore, but just since few months, so probably 2019, something like that. And then I was renewed at the end of the first mandate. So I can follow, and actually Gabriella also is one of our experts, and she joins all the governing board, but I could follow how the strategy, the European strategy developed. So you may all know that, I mean, Europe has been funding a number of machines of different computational power. So a number of so-called pre-exascale machines, actually 3 pre-exascale machines, and these are all operating at the moment. Just operating, the last one. So the first one that was going to operate, was put in operation was Lumi, which is in the north in Finland, actually very close to the Russian border. Then there was Leonardo, our high-performance computer that is now, but is located in Bologna, and it's managed by CINECA. And the third one is in Spain at the BSC Center, Barcelona Supercomputing Center, and it's called Mare Nostrum. Next to these three pre-exascale computers, there have been also, I've been funded 5 petaflop, peta computers that are spread all around Europe. So, I mean, it's starting from 0. I mean, this was a big step. And now it has been already funded by EuroHPC, the upgrade of Leonardo, for example, and Lumi, I don't know, Lumi did apply. No, Lumi couldn't apply, so Leonardo only. And launched the funding for 2 exascale computers that should be located, one in France and the other one in Germany. And we are already talking of post-exascale. Although this post-exascale upgrading is now a little bit delayed because it's urgent in terms of strategy, and this is what the Commission came to tell us in an informal governing board a few weeks ago, I mean a couple of weeks ago, that now there is the need to push towards sustain AI, and AI means large language models. And this means that there will be upgrade for all, possibility to upgrade for all these computers in the network, especially if targeted to specialize towards AI. And also funding a sort of pillar for AI. And this will probably be made by using the 400, I just look at Gabriella, 400 million euro, but we're supposed to be available for the post-exascale. So, I mean, just to give you the idea that, I mean, Europe is changing a little bit its strategy because there is the need to now, as soon as possible, give resources to a few, so far, startups that are working on foundational models, European foundational models. In the original line of work that was trying to have proprietary technologies, trying to be independent from abroad technology, which is partially true for the hardware. I mean, I don't know if Gabriella will go to tell you, because there was another initiative funded by EuroHPC, which is called EPI, which was targeted to develop our own hardware. So this is partially successful, and you know, I mean, anyhow, I mean, it still remains. But the rationale for this investment is trying to keep up with the newer technologies by developing as much as possible proprietary technologies. And of course, it's not only then a matter of technology, and this is a message to the students and to the younger people. I mean, all this massive investment means also that we need at the same time to develop skills and to, you know, educate people that can actually benefit of all this investment in terms of infrastructures. And this is both for research and for application, because also for application, I mean, if we want to really open to the wider public, let's say beyond the scientific communities, then, I mean, there should be available competencies to do this. Now, and then this is the European landscape. The Italian landscape, of course, I mean, Italy participated to EuroHPC, funded half of the Leonardo infrastructure plus all the other initiatives, where Italy, or portion of Italian research people could apply. But there has been another important initiative in Italy funded with the recovery funding money. It has been developed, one of the 5 centers of excellence, one of the 5 national centers, not say excellence, national centers, funded by the recovery money, has been dedicated to HPC. It's called X, and it is based and around, in terms of infrastructure, and around Leonardo. But it's not only Leonardo, because the center that has been funded, and it sees the involvement of almost all the community that works on HPC, and beyond that community, actually larger community, is a center that, in terms of infrastructure, of course, it has the star, which is Leonardo, but in its project has the ambition to build a network connecting all the high-performance computing centers that exist or might exist. For example, in Naples, there will be an investment with also CINECA involved money, but other actors. And so have a network of Italian high-performance computers that are together and can actually offer to the national research and industrial community a large base of computational resources. The center has also, I mean, University of L'Aquila is participating in the center, actually is participating on behalf of a consortium, larger consortium that could not participate, which is called High Performance Computing for Disaster Recovery. And the center is structured in different spokes, one that are thematic spokes that connect all the research community around certain thematic topics. And one of the spokes, spoke number 5, actually is dedicated to natural disaster and was inspired by the HPC for Disaster Recovery Consortium. So, I mean, this is all to say that there has been a huge investment in Europe, and it's going on, of course, developing now, or now looking also to quantum computing, because to some extent, I mean, part of a practical side of a quantum initiative is in EuroHPC now. I mean, actually try to keep the quantum technology that is ready to be deployed, actually to put this technology next to the high-performance computing technology, so to have it at work. And all that is needed is to, there is a large industrial interest now exploding because of AI. Now I say AI, but it's LLM. I mean, I say AI, but it's or data, or data science in general. So there is a huge interest that might not require Leonardo, but it requires extensional computational power. And this means, and what we are experiencing is that there is an incredibly lack of expertise and competencies around. As you may imagine, this kind of needs do not go slowly, but they go by, jumping. So, I mean, If there is a certain need X, then it becomes X power 10 in just a short piece of time. So we are in a hurry, and we need to develop. I say it because I'm at university. We need to develop more the educational side. There is a European initiative that is already going on with a master. There are others, so I hope that Gabriele and Fabio will fascinate the ones of you that are not yet fascinated by HPC, and it's a long run. It's not just hardware. It's software. It's it's actually modeling. So each one of us can find something to do in this landscape. Thank you.
Good morning, everybody. And thanks for this invitation to the director of Cetemps, Dottoressa Ferretti. It's a pleasure to be here with this wonderful blue sky and this warm temperature that demonstrate that the climate change is a reality, I think. Let's say our idea was to let you be more closer to what's happening in Europe and in Italy in high-performance computing. And Paola showed and mentioned the two most important initiatives, EuroHPC and the National Center for HPC, Big Data and AI, X, it's called X. I think that if it's also an Italian story of success. No? It's both of them, because Italy participated in EuroHPC, submitting a proposal in 2019 and winning the proposal for Leonardo Exascale system. So why it's an Italian story? I think because the Ministry of University and Research really has a vision more than 50 years ago, in 1969, believing that high-performance computing could have been an innovation factor for the research in Italy, and investing in a new, in particular, a new HPC center that was CINECA. CINECA has a long history, and you see here. It's, I think, a nice slide that shows all the infrastructure, the supercomputers that since the beginning CINECA designed, procured, because we don't realize, no, we buy them, we procure the system and managed, so maintained. And they are 19. And the last arrived one is Leonardo, that was inaugurated in 2022. And you see that we change a supercomputer every 3, 4, 5 years, so a life very short. And this because we need to offer to the, let's say, the research, Italian researcher, the community, and the European researcher needs to face scientific challenges that in 2, 3 years needs more power, more different architecture. So that's why we change so frequently our system. And so CINECA is a sort of, let's say, it was at the heart of the computation in Italy. And I think it was able to support the research. And a key KPI of what I'm saying is the fact that in Europe, usually the number of projects submitted at EuroHPC and previously in praise to obtain computational resources are from Italy. So the community, and the community, Italian community, is very big and very rich in high-performance computing. And probably this because for the looking of our ministry, no? But once you inaugurate and install a new supercomputer, usually for CINECA is the time to think to the next step, to the next supercomputer. So you have to imagine what you need 3-4 years in advance. So we already know in 2020, as Paola mentioned, we already participated in a new proposal for having funds for an upgrade of Leonardo that is called Lisa. I think it's understandable why Lisa, Mona Lisa. and also a quantum computer that will be integrated in 2024 in Leonardo, so another partition. And in the future also to a post-exascale system. I would like to say that CINECA is not only a center that design and buy machine. It's not only infrastructure, the topic of CINECA. CINECA always, we tried to invest in two parallel fields. Infrastructure, so we have among our employees people that are skilled in understanding the last generation CPU or GPU, the last generation of architecture, the network that we need for our supercomputer, but we also have a great number of people that works at application level, okay? So hand-to-hand with the researchers in Italy and in Europe. So we have experts in material science, we have experts, as was said, in drug design, and we work with DOMPE. We have experts in climate, in weather, in geophysics with INGV, and so on, okay? And now we need to have also experts in AI and LLM. What this kind of expertise is to help researchers to run their application on our supercomputer, and being a parallel, yes, you have. It's a particularly complex, no, to run on this system application. So we are there to help them. This is a slide that shows the supercomputer that we have at the moment in CINECA. CINECA is located in Casalecchio di Reno. It's a town close to Bologna. So we don't invest only in one supercomputer. We have a flagship supercomputer, Leonardo, the most powerful, let's say. But then we have Galileo 100 that is an HPC system, less powerful, but very, very important. For example, we run also all the meteorological models that we need at Italian and Mediterranean level. And we have also a cloud in Galileo 100. Then we have Marconi, where the aerofusion community use Marconi to perform their simulation, and so on. Now, just to give you some information regarding Leonardo, because probably you heard there was also some news that happened. Leonardo is a machine that was conceived, so designed by CINECA with EuroHPC. And it was installed, as I said, in November 2022. And in the inauguration came also our President of the Republic. Paola will remember, it was a very interesting moment because came after 3 years of work for us in the middle of COVID. It was absolutely not easy to reach this because Leonardo, as you will see, is huge and needs a new data center and we had to reconstruct during the pandemic the data center. So it was very, very challenging. And during the inauguration, a week before, we ranked this Leonardo system on the top 500 list. That is the list of the most powerful supercomputing in the world, where all the HPC data center goes to show what they achieved. And we achieved the 4th position in the top 10. So it was the first time, because we had system Fermi, I think in 2012, at position 6, if I remember correctly. So very few in the top 10. So it's a system that, as you will see, is composed by, I will show you, it's easier to show. Leonardo, as many systems in Europe, has a modular, say, architecture, partition. But this partition can be seen as a unique system. They work all together, okay? So the first partition that was installed is what we call the booster partition. And as you can imagine by the name, is this accelerated partition that perform the most part of the calculation, is the most powerful. Then at the end of 2024, we installed the general purpose partition that is going during this day in pre-production. And then there are the storage and the login nodes to let the people, the students, the researcher use the system. And just a few words about LISA, the upgrade. This is, we are designing LISA. We have not yet procured LISA, so we are starting now to receive the offer. And LISA was conceived 1.5 years ago to solve the requests, the needs of the LLM, large language model communities that suddenly appeared in our world. So these large language models are huge models like ChatGPT that needs to be trained on very large data. And for this reason, for the training, especially for the training, they need a lot of resources. But they need resources, accelerated resources in a technical means GPU, graphical unit processing, that has also have a peculiar architecture. So Leonardo, for example, was used by Mistral AI. It's a French company. It's a French company, small company, that asked to have resources and with an agreement with the French partners with the Center Agency, we decided to give them a bit of our resources, and they implemented the Mistral AI large language model that is very used. And now, for example, yesterday appeared a news of an agreement between CINECA and eGenius, I think it's called, that is an Italian company, small enterprise, that will use Leonardo to train the Italian model for the large language model. So, yes, just to say that we try to react to this request that suddenly arrived from the AI community to put and give to them the right infrastructure that, as I said, will be a bit different with respect to Leonardo. And this is a slide that I got from EuroHPC that shows the number of systems sites that EuroHPC was able to realize, because in 2018, there was nothing about that. There were several HPC centers in each country, like CINECA, Barcelona Supercomputing, Jülich in Germany, CA, Agency in France, and a few others. Okay, that invested during the years as CINECA, thanks to the funds coming from the ministries. And that's all, while China, United States were investing much more than us. So, and Europe realized that and created, as Paola said, EuroHPC initiative to boost the funding of new supercomputers, but also to boost the application and the research on these supercomputers. So let's say three pillars, infrastructure, application, but also training, EuroHPC. And in 4 or 5 years, at the moment we have 8 supercomputers in place, in operation. These are 15 and will become a reality, 15 in 2025. So you see, Lumi in Finland, Leonardo in Bologna, and Mare Nostrum 5 in Barcelona, the 3 exascale that Paola mentioned. Then there will be 2 exascales, so more powerful than our in France and in Germany in the next year. And the orange one, the yellow one that you see are our petascale system. The first one was installed in Slovenia. And then there is Meluxina in Luxembourg and so on. So a richness. I think that Europe now is the continent that invested more. So we really reacted, and I'm very proud about what EuroHPC reached, thanks also to the countries that are participating. And the green circles are the quantum computing, 6 quantum computing that will be integrated in the first. So we are proceeding quite well. This is a video that I hope will help also the communication about Leonardo. What is Leonardo? Because if you come in Bologna, maybe you can you can visit our new data center and see how Leonardo is. You see, it's a huge area, room of 600 square meters, 2 basketball field. This is the storage of 12 racks. Racks are the armadi, 12 racks only for the storage, around 100 petabytes of storage. 1 storage for archive, storage for fast I/O, okay? And then the blue one, the rows that are blue is the booster module of Leonardo. And this is a rack, and this is a blade. A blade is has the computational heart of the system. This is one node of the booster. And in this one node, you see it's composed by a CPU, Intel CPU, that is the brain of the node. And then there are 4 GPUs that, from NVIDIA. That is the booster, not the acceleration of the... And the tube that you see, this is because the system is cooled, because you can imagine all this calculation create a lot of heat, no? And you have to decrease the temperature, otherwise you burn your supercomputer. And to cool the system, we use a new, let's say, way to do that with, not with air, but with water. So enter water at 37 degrees, and the output is at 45 degrees. So we cool the system without refrigerating the water, with the normal water, 37. This is in order to decrease the energy that we consume for the cooling. we spend a lot of money for the cooling. So this is Leonardo, and this video was realized by the team in my area, Visit Lab, for the visualization. And so now, where is possible to host this big machine? And our data center in Casalecchio is too small for that. So a few years ago, 2018, we decided together with the region, Emilia-Romagna region, to receive some rooms in this area. This is an ex-tobacco factory that was creating after the Second World War for tobacco production, and that was closed around the 80s, I guess, and was designed by Pierluigi Nervi, so the famous engineer. So for this reason, and Paola knows very well, it is protected. So you can imagine that we had to restore this huge area, or part of this area, during the COVID, with the shortage of the workers, muratori, I don't know how to say in English, with the shortage of the semiconductor, and in an area that is protected by cultural heritage, that stopped us for several months to excavate, because they had to grain by grain try to understand what was under this area, and they found one skeleton under the Leonardo room, and the Leonardo room was, Paola knows, was stopped for 3 months with the EuroHPC that was asking why you are not proceeding with the work. And this area, I got a suggestion from Paola that said we have to show the similarities of the engineer that constructed. These are the botti barrels where Leonardo is now. And you see a similarity with the room Paolo VI in Vatican. I see. When I go there, it's not a normal building. It's a very nice building. And this is the infographic of what the region wish to realize, and in part they realized. The botti are there. Maybe I have this one. These are the botti. So the first 3 are the new data center of ECNWF, the European Weather Forecast Agency, that moved this data center from Reading to Bologna. The last 2 here is the data center for CINECA and INFN. So we share the same data center. And Leonardo is here, only this part is 1/3 of one botti, because the other room are conceived for other new system that will arrive during 2024 and 2025. And the region conceived this area as a scientific park that they call Tecnopolo di Bologna. The idea was to create a scientific park. So for example, we will have the civil protection. This does not exist at the moment. This is for INEA. This will be for civil protection. The new Meteo National Agency will be here. Here there will be also the university, a new university of the United Nations, ONU, for big data and artificial intelligence for managing human habitat change. That will arrive soon, I guess. Then there will be some competence industry and so on. These are the orange part is the buildings of Tecnopolo di Bologna for CINECA and FN for the supercomputers. And here we have all the equipment to provide the power to the supercomputer, but also the electrical power, but also the cooling system. And in order to, for example, bring the water for the cooling from here to here, we excavated a tunnel, 4 tunnels so big that a truck, one day we forgot a truck there inside, no? And so you can imagine in 3 years, the amount of work that we realized. Okay. What we can do with the supercomputer, here is a slide. And let's say, if I showed you more the infrastructure part of the system, now with the help also of Fabio, we will try to give you an idea of what we can do with the supercomputer, especially in the field of weather and climate sector. So you see here all the disciplines, the scientific disciplines that use usually our system. And Earth and climate science is, I think, this one, so close to 7%, not the biggest one. The computational fluidodynamics and the computational engineering is the most, let's say, community that use supercomputers. Oh, no, sono andata indietro. Sì. Okay, and now, so I am responsible of the area big data. Let's call big data now. It means data management, data analytics. What you can do on the data. Why? Because in the HPC department, we decided less than 10 years ago that it was a reality, the convergence between HPC and big data. In order to process the data, now you need resources, computational resources, and the LLM is one of these demonstration. So we created an area where now there are 35 people working, and which are the data? Which kind of example we can have about the data? I don't know if it's quite visible. This is an image that I took from ECNWF, the European Weather Agency, Forecast Agency, that shows that big data comes from observational data of our planet, no? That you can do in several ways, from radars, from radio sounds, aircraft, satellites. Copernicus is a wonderful example. You have sensor on the ships, you have sensor on the floor. So and the ECNWF collect, for example, 800 million daily observation. And with this daily observation, they realize the initialization of their model, no? Now, let's imagine observational data for climate, for example, for weather forecast, but also simulation data. These are all examples of big, huge amount of data that centers or research have to deal with. So, in the area that we created, we work with all the disciplines, but in particular, the climate and weather sector is the most advanced in terms of projects, in terms of services that we realize. So on our system, we run since 30 years the weather forecast over Italy and Mediterranean. Over Italy now with the Cosmo model at 2.2 kilometers of resolution. That is quite good. And at Mediterranean level at 5 kilometers. And all these weather forecasts are used by the National Civil Protection to, with us also other models, to understand if there is a warning that they have to issue. And these are also the asset of what is the new Italian Meteo Agency that was created 3 years ago in Italy. Another example of application and services that we provide in this sector are these two web platforms, Mistral and Highlander. This was created as the born of these two services are from European funds through H2020 research project that CINECA coordinated with all the stakeholders in the climate sector, like ARPA Emilia, ARPA Piemonte, in some cases CMCC, the climate agency. And ECNWF also. So it was European funds that arrived to solve national problems here. And which was the issue that we wanted to solve? In Italy, the data observational that the region, for example, collect, or the simulation data are sparse in the several platforms that each region has, each agency has. The simulation were in CINECA. If you want to create a new application for agriculture, if you want to create a new application for hydrology, you need to ask each partner, each region, can you give me this data where I can? This was a problem. So we created two national platforms, one for the weather forecast and one for the climate data. And now you can find in Mistral, it's an open service on all the data you need, observational data of the foreground and forecast data that I mentioned with different models. And also subservices there. On Islander, you will find the climate data. Climate data means that we realized 1 year and a half ago, thanks also to the collaboration with CMCC, the most advanced climate data over Italy. So we have a climate data set that goes from 1980s, so from the past till 2070. So 90 years of simulation for the climate. This data set is one of the most downloaded because with this data, other people can create application on this sector. This is the data set I was mentioning regarding the climate. We have also subseasonal data. And now we are working with the Agenzia Italia Meteo, not only for maintaining, so Agenzia Italia Meteo is the agency that will maintain, thanks to their fund, these two platforms. We are also working with them to have a cluster, an HPC cluster dedicated for the weather forecast. Because since now, we run the weather forecast on our Galileo 100 or the previous system. But these are systems that are for the research, so are completely open. And so run cluster for the weather forecast that are so relevant in a cluster that can be used by everybody is not always the best solution. So now we have funds to have a new cluster that will be installed in the Tecnopolo of Bologna, in one of the areas. We have also funds for a new cloud that will arrive at the end of the year, a huge cloud that will see the two data centers of CINECA and the storage that we have in Casalecchio and in Tecnopolo as one single opportunity. Now, I'm come to an end of my presentation, is one of the mission of EuroHPC, but one of the mission, of course, of CINECA is the educational, no? You know that does not exist a master degree in HPC in Italy as well as in Europe. And usually the students to be trained on these topics has to find in the university some professor that provide courses on HPC, on AI, and sometimes they can also come to our courses. So CINECA provides a catalog of courses that I wanted to say completely open and free for everybody, from the student to the PhD or researcher, or also a person that needs to be trained. So here is the reference if you are interested. Then another important project at European level that was promoted by EuroHPC, as Paola mentioned, is EU Master for HPC. As does not exist a Master for HPC, they are trying to create. At the moment, what they realized, this is the second year of this project, with almost 60 students. They are trying to realize a sort of European curriculum of HPC courses. And the student can enroll in Italy. At the moment, the university that provides these courses in this project is Politecnico di Milano. In the future, there will be more universities joining the initiatives. So these students can participate. They enroll in Polyme, and they are automatically also, if they choose HPC discipline, in EU Master for HPC, and they can follow the trainship, internship in CINECA or in other HPC center of Europe. They can move from one university to another of the network, and they can receive also some help, economic helps to be there. So this is something that I wanted to mention. And the last point is the job opportunities. Of course, the fact that the HPC is growing and the importance of this technology is, let's say, it's very wide, gave us the opportunity to CINECA to invest in new employees because we need for the new project that are coming. So every 3 months, you have to know that CINECA opens a call for new employee in the HPC department because we are facing difficulties in finding people. It's not easy to find trained people in HPC. It's still difficult. So if you are interested for the students and for the postdoc or a PhD student, you can find in our site different opportunities of work. Now I think it's the turn of Fabio.
Thank you, Gabriella, for the presentation. And I will move a little bit towards something different. I'm going to present a couple of European projects which we are involved in. And one of these is called Destination Earth. And the aim of this project is to create a digital twin of our planet. I will start with a very brief video, a couple of minutes, that explain a little bit with images what Destination Earth is. So as you have seen, is quite an ambitious project. promoted by and financed also by the European Commission. And these are the main partners. So there are the European Space Agency that is responsible for the service platform. Then there is the European Meteorological Satellite that is responsible for the data lake, where all the data produced by the project that not only will be stored. And then there is, of course, the European Center for Middle Weather Forecast that is responsible actually to create the digital twin and the digital twin engine. This is the phasing of the project. It was just launched a couple of years ago. And now we are in the first phase that should terminate this year. And this first phase involves all the three partners on the development of the core platform, as I said, by ESA, on the deployment of the data lake by the EUMETSAT, and to produce to start a couple of digital twins. One is related to the digital twin on weather-induced extreme. Another one is on climate change adaptation. And then during the next years, there will be like a transition to something more operational and more stable for long-term operations. And this is a project that should end around 2030. So we charted more in the detail the two high priority digital twins of this first phase. One of them, as I said, is related to the weather-induced extremes. Imagine to have a model that is able to run a very high resolution and to reproduce all the phenomena that happens linked to weather happens over on our Earth with a very high and time and space resolution, and to have also a twins that can run on demand. So with a resolution that can go very, very, very high in the order of 500 meters, and to have an interaction with the impact models, so that we can like forecast what will happen, for example, when a storm is approaching Europe, for example, with the precision, and to go and see where maybe there will be some problems on some disasters, so that we can have a response, take some actions, and try to mitigate this kind of effects. And this is something in collaboration with the partnership led by Meteo France. Then there is the one on climate adaptation. And this one is, of course, to create a digital twin that will move a little bit more forward in time, to have a simulation of what could be the effects of the climate change and the global warming, and to try to adapt to them to mitigate also the effect of this kind of phenomena that we are already facing, and we can see from outside today. And this is implemented by a partnership with the ICSC. And the digital twin has to have some main characteristics. So first digital twin was taught by the industry sector to represent a model of a product or something like that. And now we are using them to reproduce our Earth. One of them, of the main characteristic that a digital twin must have, is the quality. So the quality of the, for example, simulation for a weather model. Then the interactivity and the integration, and I will talk a little bit more in the next slides. So regarding the quality, we are going towards the kilometer scale globally with this kind of models. You can see on the left on this image the resolution, for example, in the climate model of the last IPCC reports was around 100 kilometers, and now we are talking about something around kilometer scale, so around 5 kilometers. You can see how the pattern in the very complex, where the orography is very complex, are completely different. So here you cannot distinguish between the flattened area and the mountains. Here you have a detail that will allow to capture also the very fine scale phenomena. And the resolution could be also higher, as I said, in particular in the weather-induced extreme digital twin, and can go down to 500 to 700 meters. And this will be a very challenge because you can imagine the computer power that it's need to run this kind of simulations. I will challenge you to understand which one is the observation and which one is the model. So as you can see here, it's almost impossible to understand which one is simulated and which one is the reality. So what do you think? Right? Who raise hand for right? Or right? 1, 2? Who raise hand for left? For modeling. Sorry, I didn't specify. For modeling. So which one? For the left one, do you think it's modeled or is observation? For model, raise your hand. Left, 1, just 1, 2 hands. And right, the rest of you, I imagine. Yeah, we're right. The right one is the model one. So, okay, you are mostly from the Cetemps, so it's easy for you. But yes, there are some patterns, some strange patterns that you can recognize that are not so, it can give you some help in understanding which one is the model one. But for me, it was really hard to, at first look, to understand which one was the observation, which one was the model. This is a simulation done, completed with the IFS model, that is the model that is run operationally at ECNWF to produce the weather forecast all around the world. And this was a simulation at 1.4 kilometer of resolution, if I don't remember wrong. And then we have interactivity. So interactivity with the system, with the digital twin, what does it mean? It means that you can play with it. So you can have a platform where you can access, you can configure as a scientist your experiment, and you can run your experiment to understand a particular phenomena or for something that you are interested in. And you can access all the data and so on. So this is another characteristic of the digital twin. And then we have the integration. So as I said, these models are really, these digital twin are really interesting for impacts. So integration means integrating the digital twin, let's say the model one, with the physical world to have like impact models to forecast, for example, forest fires or floods and so on. And this is another thing that is very important. It will be implemented in the destination Earth. And then there is the data lake that will store tons, very large amount of data with different nature. Not only meteorological data, atmospheric data, but also seismic data, for example, or renewable energy efficiency data, and so on. So will be a collection of a multidisciplinary collection of data, and this is something also very challenging. But how CINECA is involved in this destination Earth? So of course, with Leonardo, as maybe I didn't say. But part of the Leonardo EuroHPC machines will be dedicated to destination Earth. And as CINECA is one of the one that managed one of these systems, Leonardo, of course, will be involved in this, but also with the projects, more technological projects, not scientific one. One is the D360, another one is the D that is linked with the, let's say, the optimization of the models. Another one is the D330, that is the one, as I said, linked with the digital twin of extreme events, and is led by Meta France. Another one is the Glory for Destination Earth. Glory is another project that its goal is to create a digital twin using another model that is called ICON. And I show you more details in a following slide. So saying something about the 360, that is a tender with the ACNWF in optimizing some components of the destination Earth digital twin. And another objectives is to enable, for example, the cloud, that it's important for the communication, and also for the portability of the different components, and of course the training of the community for what concerns the previous two points. Regarding the first point, we are been working the last months on optimizing, for example, the ocean wave component of the IFS model, obtaining very good results and porting this model from running to CPU and running to these new systems that, as you can imagine, are also have also a different architectures. Completely different architectures respect to where they were run before. So here on the right you have, for example, a sketch representing a CPU core respect to the GPU core, and you can just understand, just thinking, looking at the colors, how the different is the architecture. I don't want to go too much in the details, but the part of silicon that is dedicated, for example, to the ALU here is much bigger respect to what was before in the CPU. Of course, there are CPUs in the new systems, but to run this kind of simulation, we have much more computational power, and to do this, we have to use GPUs. To use GPUs, you have to adapt your code to run on them. Otherwise, it will be impossible. And one of our part of this project was in doing this porting on the new architectures that are here, as already said, for example, Mare Nostrum, Lumi, and Leonardo, that are assembled with the thousands of GPUs. And okay, and then there is also another problem, so that in this different architecture, not only you have a difference from CPU to GPU, you have also difference among the GPUs. So the paradigms, the program paradigms that you use to adapt your code are not always the same or run, let's say, okay in two different systems. For example, here you have AMD GPUs for which you can use CUDA paradigms to port your code to GPU. So that we have to think about portability among the different supercomputers, and use in such a way a paradigms that can solve this role of portability. And one of these, of course, can be OpenMP for those of you that know it, or OpenACC. Then there is the other project that is called Glory for DE. Glory, as I said, is a project where there are 3 main partners that are Germany, Italy, and Switzerland. And his goal is to create a digital twin using ICON model that is used by many countries. I will show you as an operational model to do weather forecast, for example. These are the partners specific for the Glory for D to create a connection between the 2 different digital twins. One is that one, let's say, realized and deployed by Destination Earth, and the other one will be the one realized in Glory. The difference here is that in Glory, for example, there will be created 2 digital twin of a limited area, not global, but digital twins of, for example, Alps and Mediterranean. So this will allow to run the simulation at higher resolutions. Since you have a limited domain, you can also increase your resolution. You have a sketch here, for example, of the Alps, and using a resolution of 500 meters, you will be able to look inside a valley, for example, like the Rhone Valley, and to simulate that phenomena that happen at so high resolution. These are the partners, so Italia Meteo, for Italy, CINECA, ECNWF, that is the founder, the CMCC, the ARPA Emilia Romagna, and for Germany, DVD. This is something about ICON, so it's like a community model used all around the world. There are the members, common members that are mainly in Europe, and maybe Italy, Germany, and Switzerland. But as you can see, it's used in many countries. And there is also another partnership between Italy and Deutschland for create they say science for services. It's called IDEA, and to create a network in weather and climate to collaborate between Italy and Germany. So here is a little bit crowded, this slide, I don't know, but something I already said. So it should be this digital twin of Glory, customizable and on demand. That means that you can switch on and run your simulation over the 2 digital twins, the Alps and the Mediterranean, on demand when you want, and setting your experiment, for example. Global to regional means that, for example, takes the input initial and boundary conditions from destination Earth, that is runs at global scale, and use that output from destination Earth digital twin to force these 2 digital twins, or to use the ICON model to run globally and use those data to force the regional one. Then short range, it means that doesn't go to the future to have climate projections, but it's mainly for weather events, and up to 7 days. Is high resolution, as I said, it goes beyond 1 kilometer up to 500 meter, and of course it's a digital twin, as I said, and I already explained a little bit about digital twin. So for me is all. I thank you, all of you, and to invite us, Rossella Ferretti and Annalina, that is not here, to speak here in my ex-university, and thank you.
Thank you very much for your very interesting presentation. And are there any questions? No questions? I have a question. I was curious about the two satellite images that you show. I think because you talked about the IFS at 1 kilometer all over the world. There was an ISCA project on that, I remember, that we were analyzing, and he was showing about that. And I was quite, let's say, skeptical on the use of the IFS at 1 kilometer, because it's a spectral model. Spectral model, generally, it's a literature say that cannot be forced to go to such high resolution. So I was quite, but the results are really impressive. So we have to understand why they are very good results. So anyway, it was really interesting. And then the icon at very high, again, at a very high resolution. So we are starting to use icon, and with my colleague, actually, it's, as we say, a plurale majestatis. It's more his work than mine. He used the icon for simulating a tornado in Campania, and he used the icon at 400-meter resolution, and the tornado came out very, very well. It was really interesting, the results. So we have to talk about that. So anyway, I thank you very much. It was really very interesting, and I hope that the students, that I don't see much students today, actually. I saw them at the beginning, but not now.
I have one technical question, but we can discuss later. But I have a more general question about the digital transitions that, of course, all what we heard today is going in that direction, and the ecological or green transition, right? I mean, everything that we are looking at is very energy intensive, right? So what is the impact of HPC and EI and everything? I mean, how big are the pipes that you have in order to feed this kind of infrastructures? Is that sustainable? I mean, is there a plan, of course, for sustainability of this kind of infrastructures?
Let's say that that's an important topic for the HPC world, because of course these machines are very energy eating. Yes, exactly. And also our big part of our budget is for the energy that Leonardo consumes. But until we don't find a new technology like quantum computing that drastically decrease the energy cost, the only thing that, but it's not an only, a lot of work also with the universities we are doing to imagine and realize a new way to let Leonardo and the supercomputing system, the data center, very advanced in the energy consumption. So I mentioned, for example, the cooling system. This was before Leonardo. We have machines that were cooled with the air. So you have to expand cost for the air production. And others were using a cooling system with liquid cooling, but at a temperature very low. Now we realize a system, together with the engineers, that use water that we take from the Falda aquifer under Tecnopolo without cooling, and so no energy, zero energy, just to run the circuit. And the idea is to, as the water, temperature water enter in the processor, in the racks and the nodes at 37, and the output temperature is 45. The idea is to use in the future to heating our offices, for example. Some supercomputing centers already realized this. For example, of course, Lumi in Finland, they have water at 0 degrees probably, or 1. So they are facilitating this. They are using reuse. Also in Germany, they are using the heating for the offices. So there is a lot of research around this topic to also produce GPUs that are CPU that are not so much energetic consuming. No? So this is a very important topic on which we are working. But let's say, I see that really thanks to this technology, in some way you can solve, for example, during the COVID, we work with Dompe. I always like to do this example in a sort of urgent computing project to try to find which is the best molecule or a pharmaco, no, that can block the COVID. And was very interesting because we used their database. They created a database of molecules and proteins, and we run on a supercomputing system of CINECA and ENI. So just for an urgent computing, ENI decided to give computing resources for the COVID to discover which drugs can be used to, and they found something very interesting. Now, for example, we are working for a new project that is the National Center for Biodiversity, and also yes, it's interesting, I guess. Okay. Another topic that we didn't mention regarding the AI and the climate and weather sector. During the last year, I was impressed because you have seen that a lot of paper came from different.
There's an extra slide
Okay.
about AI.
Okay.
And this is from the one from ECNWF. And in red there is the FS and the square root square error, the forecast day. And the blue one is the new version just released in January 2024 of the new AI model.
Global circulation model.
And as you can see, the error is, this is for temperature, of course, not for all variables.
So a lot of work in 1 year. For example, ECNWF, I think that hired 15 people. They created a team of AI experts to run global models based only on AI, so not numerical, no? And not only CNWF, also other communities and other agencies are doing this with wonderful results, I have to say, and they say it also. And so we have a team of AI people in our group that work for using AI technologies in different scientific domains, like, for example, for downscaling dynamically, temporary, and at space, the models using just AI topics. So I remind to say also this, but I forgot.
Can I make a quick comment on this? So that basically means that now AI is already working better than a physical model, right? For temperature, at least. Yeah. And do you have any idea or insight of what happened with the other variables that are more non-linear than temperature? So it should be even more, right, performing there than for temperature, for clouds or precipitation.
Yeah, exactly. Not always. For example, it seems that the hydrological part is not working so well. So, of course, they can improve if they have more data. because I think that this model, most of the models are trained on the era 5 that has some limitation in terms of it's area analysis of the observation.
The resolution is not high.
Yeah, probably if they could have observational data at very high resolution, probably the model could run better and could perform.
The network and the regular age, something like that we do not get there.
Yes, exactly.
That's a problem.
But I mean, in 1 year, the results, in 1 year and a half, the results are really incredible, no?
And there are also big tech company involved on developing this, like Google, if I don't remember wrongly, is developing its own AI weather forecast. NVIDIA also.
Yes. Then there is also a Chinese company that uses our ERA 5 because they are open, and they produce a new model that it's open, I guess. I don't know, but yes. So.
Okay, thank you.
This means that our grandchildren would not know how the atmosphere works. I mean, they will no need to know how things works. I mean, this is the tendency. I don't know, just being skeptical. I mean, I'm just being scared by that. I just repeat this with the microphone, but the tendency is that it's not just we have to retire soon, but our grandchildren will have no needs to know how things works, how the atmosphere works. No physics, no thermodynamics, not everything else. Oh, for the fix, you mean, to fix it. Okay, but not to forecast, apparently. Just a comment.
Anyway, this is a nice topic, interesting topic. I think that if you observe the data, in some way is a way to understand the law, no? That there are behind. So it's almost what CERN is doing in Gran Sasso here. No? They observe what's happening, and they are trying to elaborate the law for the. So here we started from the simulations, and now we are doing something different, observing, doing science by data-driven science, and so which is the convergence between these. This is an interesting topic. I don't know how to answer, but it's interesting.
Is there any other question? Okay, thank you.
Thank you very much.